So that's what we're working with. I don't know how many people would be interested in something like this. I don't even know. Well, we're not seeing it. Okay, we got one. Okay,
Has to be a generator.
two. Has to be a generator. This we're not for alternators yet. Okay, not for alternators yet. That design with a couple of other changes will do alternators, and we actually also we have another design I didn't put up here for positive ground cars. We have a similar circuit that's going to be for positive ground, but we haven't built one of those yet. We don't have a donor for a positive ground car. There's many fewer of those available. Anyway, any questions about it?
I got one.
Sure, go ahead.
If you've got a battery disconnect, then obviously you're not feeding any current to the.
That's correct. You would not.
What happens when you actually connect the battery again? Is there any bad effects from that?
No, there shouldn't be. Okay. The good news about car electrical systems is you've got this big bucket. Okay, the battery that kind of keeps things pretty close. Now, you can get a little bit of noise on the line when you're turning the screw to put it back in again. The battery disconnect. But it's really not going to be enough to hurt this.
But the components are all connected. They're all protected.
They are all
surges
protected.
And spikes. And
That's correct. Yes. Okay. Now everything's protected until it isn't. Okay. I don't know every spike that can come along on everybody's TR4. Okay. But these are protected to what we think is a real belts and suspenders kind of level. Okay. But it's something that really bears testing. You never know that you don't know about something until you find it. Until you find it. Essentially, that's the way engineering goes. You try it, and if it blows up, you reconfigure. But right now, we think we're pretty good.
And that's coming from a guy who designs these things to not blow up.
Yeah, I do this for a living.
Well,
and,
I'll tell you.
That doesn't mean I can't make mistakes.
I'll tell you a story about 40 years ago now, when British Rail, on locomotives, they have voltage regulators, which are either carbon pile or segmental copper segment.
Mechanical, electromechanical.
Yeah. And these guys came in from English Electric in those days, which was in aerospace and aircraft, and said, we got these marvelous boxes, voltage regulators that are flying up in whatever they are, aircraft all the time. So we said, great, here's a locomotive, put it on, and we took this locomotive out, and 10 seconds later, poof, it had gone.
Yeah, that's...
And of course there was a big development work. But quite frankly, electronics, because of the incident with that, got a very bad reputation for many years. And in fact, when they started to measure, they didn't know anything about spikes and
because it didn't matter to the electromechanical.
That's right, for the plane up in the air, but we were measuring something like 30,000 volt spikes.
Yeah. And this would not take a 30,000 volt spike.
That's right.
Okay, but on the other hand, neither would your radio, neither would probably your headlights, things like that would blow up, which kind of, makes me think that we don't see those things. But engineering is a humbling experience. Nature has a way of humbling you. You just watch the movie Titanic. Okay, and there you go. All right, that's there's always a bigger spike coming if you wait long enough. Okay, but what you have to look at.
I think the development of obviously electronics
it's come a long way.
Come a long way.
Yeah, obviously. Okay, what you have to look at is the reliability of this going to be better than the reliability of the electromechanical regulator that you're going to put in there, and I think you can make an argument that it is.
Well,
the failure modes are different. Okay, typically the electromechanical ones wear out, like they ooze out. Okay, if this does fail, it's just going to come to a grinding halt.
Yeah.
Okay, so that's kind of what that aggravates people. Okay, because sort of you can mentally think, well, geez, it's not turning over, something's wrong. I'm going to look at this next Tuesday or something. But if it just stops when you're in the middle of the Schuylkill Expressway, that's a whole different kettle of fish.
Yeah.
Is that called Petronics theory?
I tell you what, you know, I'm not being negative, quite frankly, because I'm all in favour of this, but one of the disadvantages of the electronic, and we're talking about reliability, and I'm not a reliability guru, but I do know that reliability depends on the number of components. So in the good old, you know, electromechanical device where you've got 3 components, has theoretically a much higher reliability than an electronic device that probably has, what, 20, 30, 40, I don't know.
And inside it's got thousands of transistors,
yeah.
okay? But by that logic, this computer, which probably has 50 million or 100 million, or I don't even know how many million transistors, if you believe that, then this would never work. Okay? But,
Well, I'm not
you know...
saying that. But I'm just saying it's more likely to fail.
Yeah, you know, it used to be that when I would sell devices to the military, they would always say, how many transistors are inside? If you sell a device, if it has more transistors inside, it must inherently be less reliable than one with fewer transistors. But that's not really true, okay? That's you know, that's not the way it is anymore, okay? Those days kind of have come and gone, you know. So I think that you know, hey, it's every child. I mean, every parent thinks their child is beautiful, right? But I think that this is a good, stable design. I think it's going to stand up against the transients we see. And you know, I'm looking to get proved wrong. You know, that's what I'm. You know, it's going to take more units to do that. Yeah, go ahead.
Well, there are no changes in the basic wiring, so it's just a matter of plugging in.
The idea is it plugs right in.
If you want to carry a spare of
If
the
you want
old
to carry a spare,
reliable,
right, exactly right.
you can do it.
That's what I do. I carry my old
Yeah, he is right.
And
Yeah,
it
he.
literally takes a minute and a half to
Right.
undo 2 screws, undo 5 plugs, redo 5 plugs, redo 2 screws,
Right.
and away you go.
How universal is it going to be for you guys? This is a business question. So you can sell it to people who have MGs and.
Well, it's a good question. These kinds of things were used pretty much across the line for MGs, Morgans, and a couple of variables were, in the really old ones, they actually did have those 3 relays. The newer ones, they simplified into 2. And some have, you know, the quick connect plugs, and some have screw type. The slightly older ones have screw type plugs. And,
But the circuit won't change.
yeah.
So your board will remain the same. It'll just be the.
Yeah, I mean, unless it went to a really high current. And but the thing is, by the time they went to really high currents, they were alternators anyway.
Right.
Okay, so generators, I don't think generators went over 25 or 30 amps that I've ever seen.
And the guys we're talking about, I think, like, yeah, something like 25 max.
Yeah.
22 or 23 for a TR4.
Yeah, it's 22.
max.
Yeah, that's absolute max. Yeah, so this can handle that easily.
All right, I have a question. So now you can control to within very fine tolerance what you are recharging voltage going back to the battery.
Correct.
What did you select?
It's well, okay, that's a good question.
14, 14.4, 14.6, 14.9.
And the answer is it changes. Okay, it's kind of hard to see here, but at 20, there's in fact you can't even really see it. Okay, but one of these is a thermistor, the one on the top, I believe it is here. Okay, and so what happens is it changes with temperature. Okay, at 25 degrees C, I think the answer is 14.1?
Yeah, something like that.
I forget. I have a bunch of algebra I did. I think, I could be wrong.
That's
on
hot,
that.
right? 25 C
No,
is
that's
hot.
No, 25 degrees
25
room
is
temperature.
room
72.
75 degrees.
Yeah.
And I use the Bosch guidelines for temperature compensation.
They have a table. Okay. And the truth is, it varies a little bit anyway. And you know, ideally, what you would have is you would have the thermistor that changes the battery voltage stuck to the side of the battery. Okay, because you know it's different places under the hood. They're a few degrees different. Okay, but it's you know it's kind of approximate. You know, it's plus or minus, as the Masons say, it's plus or minus a brick. You know, I mean It's,
Ideally, you do put the temperature sensor on the battery. Because
Yeah.
if you've been charging it real hard, it's going to get warmer.
Yeah.
I just have it against the body behind this thing and out of the way of hot air coming off the exhaust manifold.
it's close, yeah.
I asked because I had an old rebuilder tell me that he set the charging systems to charge it initially 14.6 or 14.7 because the cars weren't used a lot and he wanted to have
To
them-
recharge.
He wanted to recharge a little
Yeah,
faster.
that's
than the-
not a good idea. That's not, in my opinion, that's not a good idea. That's a battery tender. Okay, you clip the battery tender on while it's in the garage. That's the right way to do that. You don't overcharge
This
it
guy
when
may
you
never
do
have
use
heard
it.
of that.
Well,
He's
well,
old
yeah.
enough that he
It's
probably-
actually not a bad idea as long as you're not having long sustained operation of the car.
Yeah, if you drive it
have
for 10 minutes.
Yeah, if you're having
that's
it
not
for a
gonna hurt
couple hours, then that's not good.
you. No, that's
This
that's-
is a good time though to mention to the group, a lot of what you said was really technical, but now that we have battery tenders, you shouldn't let the battery go dead and then count on the generator to recharge the car.
No, that's bad. That's right.
That's
For both
very-
of them.
Yeah.
For both the generator and the battery. That's bad.
Like if you do get jump started, don't think that by driving around for a couple of hours you're doing yourself any kind of favor in terms of charging
Well,
the
you
battery.
will eventually recharge it.
It's
okay?
hard on the armature though, right?
It's going to get hot.
It's going to be
It's
flat
gonna
out
get hot.
for a long time.
And what
Better to
happens?
go home and hook it up.
Yes, it is. That's exactly right. What's going to happen is that that wire has a coating on it that can melt. Okay, that's the failure mechanism. Is that wire, the insulation melts, and then the two adjacent turns will short to each other, and then the thing's no good when that happens.
And that's even more important for a car that has an alternator in it, correct? That you wouldn't want to rely on the alternator to charge the battery from dead. Maybe even less so than with a generator?
It depends. Some of the new alternator kits I've seen, you have a really, really thin wire. If you have that case, you're in trouble. If you stick
Yeah,
like a
that's a
battery
good point.
cables wire in there, you'd be okay.
Yeah,
But,
that's
you know,
yeah.
I suppose the question is, do you really want to charge your battery at 60 amps? And I guess it's okay, but coming from dead flat, maybe not such a great idea.
Yeah, you're
My
gonna.
Spitfire's been noted for 30 years.
There we go. You know,
I've never ever charged the battery.
the truth is
I've
that
replaced a few.
lead acid batteries that go in cars, almost all of them are lead acid unless you buy an Optima or something, but they're very tolerant, okay? The good news is that you can hurt them, but you gotta work at it,